Hello, today I'm giving a presentation of wired versus wireless networks. My name is William McClendon. Thank you for watching. Let's begin. There are certain characteristics of wired and wireless networks. A few of them are, for wired networks, they are interconnected to several devices in what is called the Ethernet. They also use physical mediums to transfer data, such as fiber optics cable, unshielded twisted pair, or shielded twisted pair cable. Wireless networks, or bring your own devices, their users are non-static, meaning they are mobile. An example of this is the use of cell phones and laptops. They also project information using different spectrums of electromagnetism, such as radio, infrared, and microwaves. The OSI model, the Open Systems Interconnection Model, or OSI, was developed to standardize methods of connections between devices, and having a layered interconnectivity model is a standardized method of establishing connections between devices, transmitting information and ending transmission between devices, as well as other things. According to author Stephen M. Rice, I quote, "The basic reason for using a layered networking approach is that a layered model takes a task, such as data communications, and breaks it into a series of tasks, activities, or components, each of which is defined and developed independently." The OSI model is a way of visualizing the way in which information flows inside and outside of a network. In this presentation, comparisons will be made between wired and wireless networks concerning the physical and data link layers of the OSI model. For now, I will introduce you to the OSI model, and then we will go on to talk about specifically the physical and data link layers. The first layer is the physical layer, and it is the physical structure of the network itself. This includes cables, hubs, etc. There are other processes that you can read in this slide that are conducted within each in particular layer. The second layer is the data link layer, and it deals with framing of the information. It also provides MAC addresses and communications protocols. The third layer is network, and it does what's called the packets, or the actual bits of information that's going to be transmitted. You have the transport layer, which is the fourth layer, and it ensures that messages are delivered error-free in sequence and with no loss or duplications. The fifth layer is the session layer, and it allows sessions to be established between two or more different stations. Then you have the sixth layer, which is the presentation layer, and that formats the data to be presented in the application layer so that it can be executed. The seventh layer is the application layer, and this serves as the window for users and application processes to access the network services. These are the processes within the two layers that we will be discussing. data link layer, which is layer 2, and the physical layer, which is layer 1. Now we'll talk about these layers in reference to wired and wireless networks. So in the wired physical layer, this defines the means of sending data over network devices. Again, using fiber optic cables, shielded twisted pair, unshielded twisted pair, and then you also have what's called the Ethernet IEEE 802.11a through n devices. And these devices typically are hubs and switches and routers. They're actually the peripheral devices that delegate where information goes and route the information where it's supposed to go based on addresses. Now the wireless physical layer defines the non-physical means of sending data over network devices such as radio frequencies or bandwidth, infrared waves, wireless access points, Ethernet IEEE 802.11a through n devices, which establishes guidelines for transmission, spectrums, and mediums, channels, and frequencies. Wireless devices still must utilize physical hardware such as antennas and servers, but they are not constrained by those devices, meaning they can connect to any available device as long as it has privileges to do so. On the right, we have another example within the OSI model, such as user applications, logical ports, routers, hubs, and what Department of Defense Model 4 over here correlates to what layer of the OSI model. So wireless networks refer to mediums made of electromagnetic waves such as radio waves, infrared waves, and microwaves. Although the term wireless implies that there are no strings attached to accessing the internet or network, wireless devices do require antennas or sensors to receive, transmit, and detect a wireless platform. Wireless access point is a hardware device or configured node on a local area network or LAN that allows wireless capable devices and wired networks to connect through a wireless standard, including Wi-Fi or Bluetooth. Now, wireless networks do not use wires for data or voice communication. It uses radio frequency waves. To ensure that data streams can flow at the required rate, economy of bandwidth available must be emphasized. Quote, using the amplitude shift keying or ASK digital modulation scheme or amplitude modulation AM analog modulation scheme, the two carrier waves of the same frequency are out of phase with each other by 90 degrees, a condition known as orthogonality and as quadrature. Quadrature amplitude modulation. The advantage of using QAM is that it is a higher order form of modulation, and as a result, it is able to carry more bits of information per symbol. By selecting a higher order format of QAM, the data rate of a link can be increased. QAM can be used to gain a faster data rate, but if the link deteriorates, lower orders are used to preserve the noise margin and ensure that a low bit error rate is preserved. Noise margin is defined as the amount by which a signal exceeds the minimum amount for proper operation. Now, I bring this up because when you are dealing with a wireless network, it usually doesn't have the same speed as a wired network has. There's a lot of things that can interfere with the signal, and the amount of data that is traveling along the medium there's only a certain amount or capacity for that data to be transmitted across that particular frequency. So what this does is it allows to have two transmissions that are transmitted concurrently to operate out of phase so that they don't interfere with each other. And hopefully this next slide will kind of explain that. So what's called phased modulation of a signal. Through the condition of orthogonality, the frequency is shifted 90 degrees or demodulated, thus preventing the transmission from canceling itself out. In this example, IT and QT share the same wavelength and are modulated so they do not interfere with each other. This allows for greater data rate transmission capacity. Although convenient, wireless communication had to find a way to increase transmission speed and reduce interference. Through redundant assignment of frequencies, the chances of a collision increased. This is why demodulation is so beneficial and also establishes bandwidth on different channels, aided in the ascendancy of wireless communications as well. So the blue line represents IT and the red line represents QT. And as you can see, the wavelengths are similar in nature, but they are shifted just so slightly so that they do not interfere with each other. The pathways of wireless and wired data. The Ethernet establishes connection parameters through server assignments and other protocols via connected devices, and it manages the overall network. Whereas wireless uses various transmission protocols to establish to the internet through nodes on a network using datagrams. So a wired network data link layer establishes the procedures for operating the communications link, providing frames and sequencing for transmission of data. And they use several different methods to organize the data, such as address resolution protocol, point-to-point protocol, and wireless methods also include digital subscriber lines and asynchronous transfer mode layer, or ATM. Wireless network data link layer in the OSI. When a wireless network links to a network, it uses gateways or wireless access points that allow wireless networks to access the main server through the internet. And these are just some of the ways that it does so. There are security risks involved with wired networks, such as open ports, lack of adequately configured firewalls, insufficient protocol and permissions, and employee error. With open ports, it allows hacking into network to be assumed by a client role and can be followed up by internal attacks. And you always want to close unused open ports. Lack of adequately configured firewall makes it vulnerable to malware. You should use the latest software to prevent these attacks. With employee error, human hacking of employees can cause them to give up sensitive information. So you must ensure that employees are educated on different security risks. Here are several security risks involving wireless networks: data interception, denial of service, rogue access points and wireless intruders, misconfigured APs, and misbehaving clients. These are also met with countermeasures as well. Thank you for watching this video. I appreciate your attendance.